In the skies above Tokyo on November 24, 1944, something fundamental shifted in the nature of aerial warfare. 111 Boeing B-29 superfortresses thundered across the horizon that morning, their silver fuselages gleaming in the high-altitude sunlight. These weren't ordinary bombers. They represented the cutting edge of American military technology, and they were about to teach Japanese defenders a lesson they would never forget. The formation flew at 33,600 feet, cruising through the thin, frigid air of the stratosphere. Below them, the mathematics of an impossible situation was becoming painfully clear. Japanese fighter pilots scrambled from airfields around Tokyo, climbing desperately into the cold sky. They pushed their aircraft higher and higher, straining against gravity and the thin atmosphere. But there was a hard ceiling to their ambitions. Most Japanese fighters simply could not climb above 30,000 feet effectively in combat conditions, and those that did arrived with engines screaming in protest, instrument panels trembling from the vibration, fuel gauges pointing toward empty. The B-29's, by contrast, cruised at their operational altitude with casual superiority, dropping their ordnance from heights that anti-aircraft batteries couldn't reach, moving at speeds many enemy interceptors couldn't match even in level flight. This wasn't a minor tactical advantage, it was the difference between a solvable problem and an impossible one. What Japan's military leaders had dismissed months earlier as propaganda was proving devastatingly, undeniably real. The B-29 superfortress wasn't just another bomber in a long line of bombing campaigns. It was a revolutionary weapon system that operated in a completely different dimension, one where Japanese technology couldn't effectively compete. For the pilots tasked with defending their homeland, this truth brought something worse than tactical defeat. It brought psychological devastation. How do you fight an enemy floating serenely above you? Untouchable, unassailable. The path to this moment had begun half a year earlier, in June 1944, when American forces captured 3 critical islands in the Mariana Chain. Saipan fell first, then Tinian, then Guam. Japanese military intelligence understood the implications instantly. From these bases, the new B-29's could reach virtually every major city on the Japanese mainland and return safely to their starting points. The homeland that had never been successfully invaded now lay exposed to assault from the air. The B-29 program had consumed an almost incomprehensible amount of resources. $3 billion had flowed into its development, more than the Manhattan Project itself had cost at $2 billion. Every single aircraft incorporated revolutionary technologies that seemed to belong to a future generation of aviation. The crew compartments were pressurized, allowing men to work in shirt-sleeve comfort while conducting their duties at extreme altitudes. Centralized fire control systems with analog computers directed multiple gun turrets with precision human hands couldn't match. The Wright R-3350 engines incorporated turbochargers that maintained power in the thin air of the upper atmosphere, where other engines simply gasped and choked. The first B-29 to reach the Mariana Islands touched down on Saipan on October 12, 1944. The aircraft was named Jolton Josie, the Pacific Pioneer, and it landed with General Hansel at the controls. Brigadier General Haywood S. Hansel, Jr. had assumed command of the 21st Bomber Command just 2 months earlier, in August, bringing with him extensive experience in strategic bombing planning. Under his leadership, the bombers were being prepared for their offensive mission. The specifications told a stark story of technological dominance. The B-29's tested maximum ceiling stood at 40,600 feet. Its operational ceiling, the altitude at which it could effectively fight, was 33,600 feet. Japanese fighters, by comparison, struggled to exceed 30,000 feet in actual combat conditions. The Mitsubishi A6M-0, Japan's most famous fighter, had theoretical ceilings that varied by model, but in combat configuration carrying full fuel and ammunition, rarely operated effectively above 30,000 feet. Some variants could theoretically reach higher, but theory and reality were strangers in this war. Before the November 24th raid, reconnaissance missions had already begun gathering intelligence. On November 3, 1944, an F-13 photo reconnaissance variant of the B-29, sent by the 3rd Photographic Reconnaissance Squadron, flew over Tokyo. It was the first American aircraft over the city since the Doolittle raid years earlier. This single reconnaissance flight revealed something shocking to Japanese commanders. Their air defenses were completely unable to intercept aircraft operating at high altitude. Throughout early November, more F-13 sorties probed over the Tokyo-Yokosuka area, photographing aircraft factories and port facilities. These reconnaissance birds generally managed to evade the heavy anti-aircraft fire they attracted, and the numerous Japanese fighters scrambled to intercept them. The pattern was becoming clear. High altitude was sanctuary. On the morning of November 24, 1944, General Emmett O'Donnell led 101 B-29's toward the Nakajima aircraft factory. The raid came in at 30,000 feet, where the superfortresses were far safer from Japanese anti-aircraft fire. Japanese radar operators spotted the incoming formation while it was still 200 miles away. Fighter squadrons scrambled from airfields surrounding Tokyo. Pilots knew they faced a climbing battle against both altitude and time. Would they reach the bombers before fuel ran out? Would their engines hold together in the cold, thin air? The results shocked every defender involved. Only 48 bombs struck anywhere close to the factory. The jet stream winds and thick clouds made accurate bombing nearly impossible. This tactical failure might have seemed significant, but it paled compared to the strategic revelation that was unfolding. Japanese fighters could not effectively intercept these bombers. Most interceptors never reached the B-29's altitude. Those that managed to climb that high arrived with engines overheating from the strain, controls sluggish from the thin air, and only minutes of fuel remaining for combat operations. The Nakajima Ki-84 Hayate was among Japan's best fighters. Theoretically, its operational ceiling should have enabled it to intercept B-29's, but that assumption required perfect conditions, reduced fuel loads, and high-quality fuel. Japan no longer possessed high-quality fuel. In reality, most Japanese fighters became combat ineffective above 25,000 feet. The disparity in operational ceilings created unprecedented challenges for Japanese air defense planners. The problem wasn't simply that B-29's flew higher. They maintained full combat effectiveness at altitudes where Japanese aircraft could barely function, where engines sputtered and pilots struggled for consciousness. The Mitsubishi A6M30 carried a listed service ceiling of 36,250 feet, but this was achievable only under absolutely perfect conditions, with minimal fuel and minimal ammunition load. Combat reports from Japanese pilots showed that Zeros rarely operated effectively above 30,000 feet. When they attempted to intercept B-29's at cruising altitude, they typically failed completely. Meanwhile, the B-29's maintained full combat capability through revolutionary design features. Their pressurized cabins meant crews operated in relative comfort, while Japanese pilots suffered from extreme cold that seemed to penetrate bone and blood. At 33,000 feet, temperatures dropped to -50 degrees Fahrenheit. Japanese pilots lacked adequate heating systems or proper cold weather gear for extended high-altitude operations. They froze while American crews worked in warmth. The fundamental problem facing Japanese pilots went beyond simple altitude numbers. It touched the physics of aviation itself. Aircraft engines lose power progressively as air density decreases with altitude. The B-29's Wright R3350 engines incorporated turbo superchargers manufactured by General Electric. These remarkable devices used exhaust gases to compress intake air, maintaining sea-level power output up to the critical altitude. Japanese aircraft engines lacked effective turbocharging. They lost power steadily with altitude, their performance degrading with every 1,000 feet climbed. As months passed and interception attempts repeatedly failed, Japanese fighter pilots increasingly perceived their efforts as futile. Beginning in August 1944, some Japanese aircraft had started conducting suicide ramming attacks on B-29's. By October, several specialized kamikaze fighter units had been officially established. By war's end, ramming tactics had destroyed 9 B-29's and damaged 13 others. The price was 21 Japanese fighters lost. The United States Strategic Bombing Survey, conducted after the war, provided comprehensive analysis of the entire campaign. B-29's flew 31,387 sorties against Japan, dropping 169,676 tons of ordnance. Total losses were 414 aircraft. The loss rate worked out to 1.3%. Japanese fighters accounted for only a small fraction of these losses. Most B-29s that didn't return to base were lost to mechanical failure and operational accidents rather than enemy action. The altitude crisis sparked frantic attempts at technological solutions within Japanese aircraft design bureaus. The 244th Sentai, under Captain Teruhiko Kobayashi, pioneered organized ramming attacks against B-29s, beginning on December 3, 1944. Kobayashi's pilots claimed 6 B-29s destroyed through deliberate collisions, with all pilots surviving by bailing out after impact. This extreme tactic arose from a simple fact. Conventional interception at B-29 altitudes was nearly impossible. Major Kobayashi, who became the youngest Sentai leader in the Japanese Army Air Force when he took command of the 244th in November 1944, eventually achieved 5 confirmed kills, including 3 B-29s. But these victories came through ramming attacks and low-altitude interceptions, not conventional high-altitude combat. Standard fighter tactics were simply irrelevant at these altitudes. The Japanese military developed several experimental high-altitude interceptors. The Mitsubishi J-2M Raiden was modified with a turbocharger, theoretically capable of reaching 38,000 feet. The turbocharger proved unreliable, though. Only 35 turbocharger-equipped variants were ever built. The Kawasaki Ki-108 featured a pressurized cockpit, one of the few Japanese attempts at cabin pressurization. 4 prototypes were constructed, but the program was abandoned after a fatal pressurization system failure during testing killed the pilot. The Tachikawa Ki-94 was designed specifically for high-altitude interception, with a pressurized cockpit and turbocharged engine theoretically capable of reaching 45,000 feet. The war ended with only 2 prototypes partially completed. Japan's aviation fuel had deteriorated dramatically by late 1944. American aircraft burned 100-octane fuel, later upgraded to 115-octane. Japanese fuel had degraded to 87-octane or lower. This difference had catastrophic effects at altitude. Lower octane fuel caused engine knock and detonation. Pilots were forced to reduce throttle to prevent engine destruction, losing power at the exact moment they needed it most. This power reduction, combined with the severe power loss from altitude itself, left Japanese fighters unable to climb to B-29 operating heights or maneuver effectively once there. Climbing to interception altitude consumed 3 times normal fuel consumption. Many fighters exhausted their fuel before reaching the B-29s, or had only minutes of combat time available before being forced to disengage and glide back to base. The fuel shortage created a vicious cycle. Attempts at interception consumed irreplaceable resources while achieving minimal results. Every scrambled mission burned fuel that would never be replaced. Every failed intercept represented resources squandered for nothing. Japanese pilots encountered another shocking reality when facing the B-29s. The jet stream. These high-altitude winds could exceed 200 miles per hour. American navigators learned to use these winds to their advantage, positioning their formations to gain ground speed advantages. Japanese interceptors found the jet stream an insurmountable obstacle. B-29s flying from the Marianas could achieve ground speeds exceeding 500 miles per hour when flying with the jet stream. Japanese fighters struggling to climb against the wind seemed to stand virtually still in comparison. The jet stream's existence had been theorized by Japanese meteorologists, but they lacked the high-altitude capability to study or measure it properly. When Major General Curtis LeMay took command of 21st Bomber Command in January 1945, he revolutionized B-29 tactics completely. On March 9th and 10th, 1945, he sent 334 B-29s against Tokyo at night, flying at just 5,000 to 7,000 feet. This shift to low-altitude night raids might have given Japanese fighters an opportunity to score victories. Instead, it presented entirely different challenges. The Americans suffered few losses from Japanese fighters during the night raids, which continued monthly from March 1945 until war's end. Japanese night fighter capability was primitive at best. Most pilots lacked instrument flying training, and ground control lacked effective radar guidance. The March 9th and 10th raid destroyed 267,000 buildings and nearly 25% of Tokyo's urban area. Of the 334 B-29's over the city that night, only 14 were lost, mostly to the violent updrafts from the massive firestorm created by incendiary bombs rather than to enemy action. The raid killed an estimated 100,000 civilians and demonstrated something profound. B-29's could operate with near impunity, regardless of altitude. By early 1945, Japan's ability to mount high-altitude interceptions had completely collapsed. Aircraft maintenance standards degraded due to chronic shortages of parts, tools, and experienced mechanics. Pilot training programs were shortened from 2 years to just 3 months, producing aviators incapable of the complex skills required for high-altitude interception. Resistance to air raids decreased sharply beginning in April 1945. On April 15th, the Imperial Japanese Army Air Force and Navy Air Defense units were finally placed under a single command when the Air General Army was formed under General Masakazu Kawabe. But by this time, fighter effectiveness had already been destroyed. The 343rd Naval Air Group formed in December 1944 under Captain Minoru Genda, specifically tasked with home defense, assembled Japan's surviving aces flying the best available fighters. Yet even they could not overcome the laws of physics that prevented effective interception at B-29 altitudes. The situation became completely hopeless when P-51 Mustangs began escorting B-29's from Iwo Jima in April 1945. On April 7th, the raid on Tokyo was the first escorted by Iwo Jima-based P-51 Mustangs, very long-range fighters from the 7th Fighter Command. The Americans claimed 101 Japanese aircraft shot down for the loss of 2 P-51s and 7 B-29's. The introduction of fighter escort meant Japanese pilots faced not just untouchable bombers, but also fighters with their own superiority in the air. Bombing accuracy improved dramatically as the campaign progressed. In November 1944, only 20% of airborne aircraft bombed the primary target, and 20% failed to bomb any target at all. By March 1945, 85% bombed the primary target. In July, the percentage climbed to 94%. This dramatic improvement came partly from eliminating Japanese fighter opposition and from improved tactics developed through hard experience. The ultimate demonstration of altitude superiority came with the atomic bomb missions. Practice missions by the 509th Composite Group flew at 30,000 feet, beyond the effective range of most anti-aircraft guns. Japanese fighters did not attempt to intercept these aircraft. On August 6, 1945, the Enola Gay dropped the first atomic bomb on Hiroshima from 31,060 feet. On August 9th, Bockscar dropped the second bomb on Nagasaki from 28,900 feet. Both missions proceeded without fighter opposition. Japanese interceptors simply could not reach these altitudes effectively. The last air combat of World War II illustrated the confusion plaguing Japanese air defense. On August 18, 1945, Saburo Sakai participated in the Japanese Navy's final wartime mission by attacking 2 reconnaissance consolidated B-32 Dominators, aircraft he initially misidentified as B-29 superfortresses. The encounter occurred at 6,000 meters, approximately 20,000 feet, where Sakai observed the aircraft clearly and noted the enormous single vertical stabilizer swept upward toward the rear, characteristics of the B-32 rather than the B-29. This final combat, occurring after Japan's surrender on August 15th, resulted in the death of Sergeant Anthony Martin, the last American combat casualty of the war. Each B-29 represented technologies Japan had simply not developed. Constant speed propellers with electric pitch control, turbo-supercharged engines, centralized fire control systems incorporating analog computers, pressurized cabins with heating and cooling systems, all represented capabilities decades beyond Japanese manufacturing. Each aircraft required over 13 tons of aluminum, half a ton of copper, 600,000 rivets, 9.5 miles of wiring, and 2 miles of tubing. American factories produced these components using mass production techniques Japan had never implemented effectively. While Japanese aircraft were still partially hand-built by skilled craftsmen, American assembly lines produced B-29's using standardized parts and processes refined through careful engineering. By October 1944, 21st Bomber Command units were spread from Colorado Springs to the Marianas, with total strength reaching 43,000 personnel. This massive organizational effort demonstrated American logistical superiority as clearly as the B-29's demonstrated technological dominance. By August 1945, the 21st Bomber Command had destroyed a substantial percentage of Japanese industry, wrecked her economy, and shattered the morale of her people. The systematic destruction proceeded through distinct phases targeting specific industries and areas. The 21st Bomber Command attacked Tokyo 3 times between November 27th and December 3rd. 2 of these raids targeted the Musashino aircraft plant, while the other struck an industrial area with M69 incendiary cluster bombs. On February 25, 1945, 172 B-29's dropping incendiaries destroyed 28,000 buildings, proving definitively the effectiveness of incendiary weapons against Japanese urban areas. On April 2nd, more than 100 B-29 bombers attacked the Nakajima aircraft factory. On April 7th, 101 B-29 bombers attacked the same factory again. On April 13th, more than 300 B-29 bombers attacked military targets in and around Tokyo. The bombing campaign systematically destroyed Japan's industrial capacity. Raids on aircraft factories eliminated her ability to replace combat losses or develop new designs. The Nakajima plant at Musashino was repeatedly targeted. It never recovered full production. Oil refining facilities faced systematic attack. Refineries were destroyed or crippled repeatedly. Aviation fuel production dropped to negligible levels by mid-1945. The bombing campaign's destruction extended far beyond military targets. Supply lines broke down as waves of B-29's pounded railway yards and shipping ports, cutting off the flow of materials and food throughout the nation. On the 25th of May in 1945 alone, 464 superfortresses struck the Yamamoto district in a devastating assault. Official reports from the Metropolitan Police documented 3,352 deaths and the destruction of 166,000 buildings in that single raid. Even Tokyo Station fell victim to the bombardment, as did the grand main structure of the Imperial Palace, a building constructed during the Meiji era and considered the heart of the nation's identity. What made the B-29 truly formidable was not any single breakthrough, but rather how American engineers had woven multiple technologies together into one integrated system. The secret lay in combining different innovations into something greater than the sum of its parts. The turbocharging system represented one crucial element. General Electric's design used hot exhaust gases from the engines to compress incoming air, a technique that allowed the massive Wright engines to maintain full power even when flying at altitudes where the air grew thin. Japan had attempted turbocharging before, but lacked both the advanced metallurgy and the precision manufacturing capabilities needed to produce units reliable enough for combat service. Pressurization formed another vital component. Inside the B-29's sealed compartments, the air pressure was maintained at a level equivalent to 8,000 feet altitude, even when the aircraft climbed above 30,000 feet. This meant that American crews could perform their duties without constantly breathing from oxygen masks, remaining alert and effective during long missions. Japanese aircraft had no such systems, forcing their pilots and crews to endure oxygen deprivation at high altitude, limiting how long they could operate effectively or how high they could climb. The Wright R-3350 duplex Cyclone engine powering each B-29 was itself an engineering marvel. 18 cylinders arranged in 2 rows generated 2,200 horsepower when the turbocharger kicked in. Japanese engines, though reliable enough at lower altitudes, simply could not match this performance at height. As the air thinned, Japanese engines gasped and weakened, while the turbocharged American engines maintained their power. The fire control system represented another revolutionary advantage. Rather than relying on gunners' eyesight and experience alone, the B-29 mounted a centralized system using analog computers to calculate firing solutions automatically. These machines determined the correct lead angle and accounted for bullet drop through thin air, doing in seconds what would have taken human calculation far longer. Gunners could coordinate their fire through this system, with one operator controlling multiple turrets to create overlapping fields of defensive fire that proved devastatingly effective. Japanese pilots attacking from below, the only angle available to them given the altitude gap, found themselves caught in crossfire they could barely escape. Yet technology alone cannot fully explain what happened. The human dimension remained profound and tragic. Japanese pilots displayed courage that bordered on the superhuman, launching attacks they knew stood almost no chance of success. They pushed their engines to the limit, climbing higher and higher as the engines strained and the air grew colder. Ice accumulated on their windscreens and wings, their vision blurred as oxygen grew scarce. Many lost consciousness during the climb. They knew with increasing certainty that they would never reach the Americans flying serenely miles above them. The cumulative failure to stop even a single B-29 raid weighed heavily on everyone, not just the pilots themselves. The entire Japanese population watched their defenders scramble into the sky, watched them climb, and watched them return defeated, having never even reached combat altitude. The psychological impact proved enormous. Citizens understood what the failures meant. Their defenders could not stop the bombing. Nothing could protect them from the sky. The training situation had deteriorated terribly by this stage of the war. Replacement pilots arrived at their units with fewer than 100 flight hours in their logbooks, compared to the 500 hours or more that pilots who entered service earlier in the conflict had received. These inexperienced young men lacked the skills necessary for the complex demands of high-altitude flying, making successful interception even more impossible. They were children being sent to fight against a superior enemy with inadequate preparation. Maintenance failures compounded this crisis. By spring 1945, Japanese aircraft availability had dropped below 40%. The sophisticated fighters needed for high-altitude combat required meticulous maintenance, but parts had grown scarce, tools were worn out, and experienced mechanics had been lost to combat or reassignment. When pilots attempted to climb toward the B-29's, their engines sometimes failed partway through. Some pilots faced the horror of canopies that jammed shut, trapping them in their doomed aircraft as they fell from the sky. The B-29 campaign achieved something far more than simply dropping tonnage of bombs. Operating at altitudes beyond fighter reach allowed multiple different tactics simultaneously. During daylight hours, the B-29's attempted precision bombing raids, though jet stream winds often scattered their bombs across wider areas than hoped. Yet even these imprecise raids proceeded without the catastrophic losses that conventional bombers had suffered earlier in the war. During darkness, entire fleets switched to low-altitude tactics, approaching at night to conduct area bombing that devastated Japanese cities while still remaining largely beyond fighter opposition. Mining operations represented another use. Thousands of mines dropped by B-29's choked Japanese harbors and shipping lanes, effectively blockading the home islands from the outside world. These mining missions encountered almost no opposition whatsoever. Reconnaissance flights photographed Japanese defenses with complete impunity, providing military planners with detailed intelligence for the invasion planning that ultimately became unnecessary. The psychological warfare component proved equally important. Leaflets scattered across cities warned civilians of impending raids, eroding morale and demonstrating the nation's helplessness. The contrast between Japanese military promises and American capability created a growing disconnect that undermined public confidence in leadership. When Emperor Hirohito finally announced surrender on the radio, he specifically referenced a new and most cruel bomb, referring to the atomic weapons. Yet the context for that surrender decision extended far beyond the two atomic explosions. Years of relentless B-29 raids had already torn apart the nation's fabric. The military leaders who gathered in the Imperial Conference did not debate whether they could win. They discussed whether they could even defend their remaining cities against what was coming next. They knew the answer was no. Military commanders admitted openly that B-29's could not be stopped. The destruction would continue until nothing remained. The atomic bombs provided a convenient justification for surrender, allowing leaders to yield without appearing to have simply given up. But the conventional bombing campaign had already made defeat inevitable. Utaka Akabani, a senior government official, later reflected that the raids on medium and smaller cities had caused the worst damage and most demoralization among ordinary people. The experience had reached into every community. By August 1945, Japanese industrial output had collapsed to less than 15% of what it had been at its peak. Factories stood destroyed or idle. The workforce had been decimated by bombing, conscription, and the chaos of societal breakdown. The altitude advantage possessed by the B-29 over Japanese fighters offers lessons that military strategists continue studying today. Domain control emerged as the critical concept. When one side can operate effectively in an environment where the enemy cannot, that becomes decisive. The B-29's proved this principle by operating above the fighter ceiling of every Japanese aircraft. They operated in a domain where they faced no real opposition, a domain the Japanese simply could not enter. This concept would reshape military thinking for decades to come. Rather than traditional superiority measured in numbers of aircraft or pilots, the idea of controlling specific domains where enemies cannot operate became central to strategy. Altitude proved to be the first such domain. Later, space and cyberspace would become equally important. Victory came not from individual technologies, but from weaving multiple systems together into one effective whole. Turbocharging, pressurization, fire control, navigation all had to work together reliably. This integration proved more decisive than any single innovation. American crews received extensive training in the complex procedures needed to operate the B-29 systems effectively. Training and doctrine mattered as much as hardware. Ultimately, military power rested on industrial capacity. America produced nearly 4,000 B-29s while maintaining consistent quality and reliability. This manufacturing capability demonstrated industrial supremacy that proved as decisive as any victory on a battlefield. The Soviets, after reverse engineering captured B-29s into their own Tu-4 design, made high-altitude performance a priority in all future bomber development. The need for fighters capable of intercepting high-altitude bombers accelerated jet fighter development worldwide. Nations raced to create surface-to-air missile systems that could reach bombers flying at previously unattainable heights. Decades later, former enemies met at aviation reunions. Japanese pilots who had attempted their desperate climbs spoke with American B-29 crews who had watched from altitude. These conversations revealed something unexpected. Both sides harbored deep mutual respect. Americans acknowledged the extraordinary courage displayed by Japanese pilots attempting what was physically impossible. Japanese aviators admitted they had known since early 1945 that their efforts were hopeless, yet they continued from a sense of duty and the shame they would feel at surrender. The shared experience of aerial combat, though separated by miles of altitude, created bonds between former enemies that transcended the conflict. Japan's post-war aviation industry bore the marks of this experience. Every specification for Japan's new self-defense force aircraft emphasized one thing above all else: high-altitude performance. Never again would Japanese pilots find themselves unable to reach an enemy. The trauma of watching B-29s fly serenely above their maximum altitude influenced Japanese aerospace development for generations. The altitude gap measured roughly 3 miles, somewhere between 15 and 18,000 feet, separating B-29 cruising altitude from the ceiling of Japan's best fighters. This vertical separation determined the outcome of the war. Those thousands of feet made the difference between effective air defense and helpless observation, while destruction reigned from above. Japanese pilots experienced their technological shock in predictable stages. First came disbelief that aircraft could even operate at such altitudes, then denial that the altitude advantage really mattered all that much. Desperate attempts at innovation followed, schemes and modifications to somehow bridge the gap. Finally came resignation to technological inferiority, the painful acceptance that they simply could not compete with American engineering and industrial capacity. This psychological journey mirrored Japan's broader transformation from confidence and imperial ambition to acknowledgement of total defeat. For Americans, the B-29 vindicated the theory of strategic bombing while proving the absolute necessity of technological superiority. By operating above enemy defenses, bombing shifted from a costly game of attrition where losses mounted dangerously to systematic destruction executed at acceptable cost. The campaign demonstrated that properly equipped and intelligently employed air power could prove decisive in modern warfare. Understanding the B-29's success requires looking beyond the aircraft itself. The island-hopping campaign across the Pacific had captured the Mariana Islands, bringing Japan within B-29 operating range. Without these bases, the altitude advantage would have meant nothing. American submarines had already devastated Japanese merchant shipping, starving factories of raw materials. Code breaking gave American intelligence complete knowledge of Japanese fighter deployments, allowing B-29 routes to avoid the strongest defenses. American industrial mobilization produced not just B-29's, but trained crews, spare parts, and fuel for forward bases scattered across the Pacific. This comprehensive superiority extended far beyond mere technology. The B-29 campaign succeeded not in isolation, but as one component of an integrated strategy that attacked Japan simultaneously from multiple directions. The altitude advantage multiplied the effectiveness of everything else, creating a synergy that accelerated Japan's collapse. The B-29 represented something revolutionary in military aviation, going beyond simple performance metrics. It demonstrated that complex machinery could be both reliable and mass-produced. Thousands of B-29's flew thousands of missions, with a reliability rate that amazed even American engineers. The aircraft proved that complexity did not mean fragility, that intricate systems could perform dependably in harsh combat conditions. Integration proved more important than individual excellence. Sophisticated fire control systems worked better than individual gunner skill. Coordinated crews operating as teams within complex aircraft proved more effective than individual pilot courage. Industrial methods applied to warfare transformed military production. Assembly line techniques that had built automobiles now produced sophisticated weapon systems. Technology had become decisive. An altitude advantage could render traditional military virtues almost irrelevant. This revolution would reshape all military development that followed. The emphasis shifted fundamentally from individual warrior skills to technological systems, from craft production methods to industrial assembly, from tactical excellence to strategic capability. The Japanese pilots climbing toward unreachable B-29's represented more than tactical defeat. They embodied a collision between technological reality and military mythology. The Japanese military had constructed its entire identity around claims of spiritual superiority, compensating for material disadvantages through appeals to the Bushido code and samurai tradition. The B-29 flying calmly above the reach of Japan's finest pilots and most modern fighters proved this fundamental assumption catastrophically wrong. Spirit could not soar to 30,000 feet. Courage could not compress air into engines. Determination could not overcome physics. The B-29 force expanded with stunning speed. 9 months transformed a single bomb group with 119 aircraft into 5 complete wings, fielding 1,000 superfortresses. Operating primarily from bases in the Mariana Islands, these aircraft systematically destroyed Japan's war-making capacity while suffering minimal losses to enemy action. The numbers tell only part of the story. Behind every statistic were individual Japanese pilots climbing into thinning air, knowing they would likely never reach combat altitude. Their engines screamed under the strain. Consciousness faded as oxygen grew scarce. Their aircraft became harder to control as ice accumulated on surfaces. They watched helplessly as American bombers proceeded unopposed overhead, destroying their cities and their nation's future. They were young men sacrificed to a technological gap they could not bridge. The legacy of those unreachable altitudes persists in modern military doctrine that emphasizes maintaining technological dominance and operating in domains where adversaries cannot contest effectively. Whether altitude, space, or cyberspace, that principle remains. If you can operate somewhere the enemy cannot reach, you possess a decisive advantage. The B-29s flying above Japanese fighter ceilings were not merely conducting bombing raids, they were demonstrating a new paradigm of warfare, one where technology triumphs over tradition, where industrial capability defeats ideology, and where physics overcomes philosophy. The Japanese pilots witnessing B-29s at unreachable altitude were seeing the future of warfare unfold above them. Their attempted interceptions, though doomed from the start, deserve acknowledgement and respect. Their failure was predetermined by technological reality. In those desperate climbs toward bombers they could never touch, they encountered the defining truth of modern conflict. Victory belongs not to the brave alone, but to those positioned where their enemies cannot reach them. The human tragedy underlying the technological triumph must not be forgotten. Young men on both sides found themselves caught in a conflict where the outcome had been determined by industrial capacity and engineering capability rather than individual courage. American crews and Japanese pilots never wanted this impossible war for the sky. The B-29s gliding serenely above desperate Japanese interceptors became the perfect symbol for the Pacific conflict. American industrial might operating beyond the reach of Japanese capability, delivering inevitable victory through sheer manufacturing supremacy. That terrible moment when Japanese pilots understood they could not reach the bombers destroying their homeland echoes through history as a reminder that in modern warfare, technological superiority can render traditional military values irrelevant. The B-29s did more than simply fly above Japanese fighter ceilings. They flew above an entire worldview rooted in the belief that spiritual superiority could overcome material disadvantage. In those unreachable altitudes, the industrial age of warfare triumphed definitively over the age of the individual warrior, writing the future of combat in contrails traced across the stratosphere for all to see.